Okay, now recording. All right, so I was going to do a few more problems from section 3.6 on the logarithmic differentiation. And I probably won't go too long, and then I'll stop and we'll go ahead and take the quiz, and then that'll be it. Okay. All right, so back to 3.6. Key things you want to put on your cheat sheet. Okay, so on page 218, box 2, derivative of natural log of x is 1 over x. If you have a different base, derivative with respect to x of log base b of x is 1 over x ln b. So like if you have log base 10 of x, the derivative is 1 over x ln 10. So a little bit more clumsy. Okay. I didn't show you this on the top of 219, but it's basically, of course, you can use ln with a chain rule. Okay. So maybe this box over here, the derivative of ln g of x, you go 1 over g of x times the derivative of g of x, which is g prime of x, right? Okay. Number 4, you don't really need it that much, but go ahead and put it down. We're going to get to that more in chapter 5, but it's good to know if you see an absolute value, don't let it throw you off. The derivative of ln absolute value of x is also 1 over x. And then we have the logarithmic differentiation that I've shown you before. Now, the steps are here on page 221. They're correct. There's nothing wrong with it, but it always turns out to be the same thing. You can simplify it. Take the natural log of both sides, simplify by laws of logs. Okay. Part 2, you can even get more specific. The left side is inevitably going to be 1 over y dy dx. And then for number 3, you would just multiply both sides by y. Okay. So we did some yesterday, and we'll do more. Okay. 3.6 problem 39. It says to do it by logarithmic differentiation. Okay. Now you realize you can do that one without logarithmic differentiation also, right? You can just do the regular product rule and chain rule stuff, right? Okay, so take the natural log of both sides. So ln, ln. Once you have the ln, the ball can get rolling. Okay, so I have a product. So ln of this plus ln of this. And then the 2 can come down and the 4 can come down. Okay, and that makes it much, much nicer, much easier to take derivatives now. Okay. All right, so the left side's always the same. It's 1 over y dy dx. Derivative of this is 2 times 1 over x squared plus 2 times the derivative of x squared plus 2, which is 2x, plus 4 times 1 over x to the 4th plus 4 times the derivative of x to the 4th plus 4, which is 4x cubed. Okay. And the last step is just multiply both sides by y, but in your final answer, don't leave it as y, write what it originally was. And normally we sneak it in front. Okay. Now, when I get to this step, there's not enough room to put it in front, but now that I'm writing another step, you normally sneak in the y right here. So final answer dy dx is the original y. Just copy all this stuff. And then you multiply it by this extra factor, which cleaning up is 4x over x squared plus 2. And this is 16x cubed over x to the 4th plus 4. Okay, so that's the final answer. Okay, so notice this is the typical way to do logarithmic differentiation. Okay, take the ln of both sides. Use property of logs. So this is a product, so I can make it ln of the first plus ln of the second. And then even more than that, these exponents get to come down. 2 comes down, 4 comes down. Okay. Then it's a lot easier to differentiate. Okay. The left side's always going to be the same. So the directions they give you in the book for part 2, it's correct, but we can even get more specific. The left side's always going to be 1 over y dy dx. Then take the derivative of the right-hand side and then multiply both sides by y, but don't leave it as y. Write what it was. What was it? this stuff, x squared plus 2 squared, x to the fourth plus 4 to the fourth. So that y I put in front right over here. And then times this extra factor cleaned up is 4x over x squared plus 2, 16x cubed over x to the fourth plus 4. Okay. Okay, I was going to show you 45 also. This falls under the category of a variable raised to a variable expression. So remember, when you have a variable to a variable, you have to do logarithmic differentiation. So I can quickly review what I showed you last time. Okay, so I showed you this the other day. If you have a variable to a constant, like x squared, that's the power root. So the derivative is 2x. If you have the other way, constant raised to a variable, do not do x 2 to the x minus 1. This is a property of exponentials. So this one would be 2 to the x ln 2. The third case is variable expression to a variable expression. Then you have to do the logarithmic differentiation stuff, like x to the x. So again, don't go x to the x minus 1. Okay, so variable expression to a variable expression, logarithmic differentiation. And again, I didn't put down a constant to a constant, but you know, constant to a constant is still a constant, so the derivative is 0. That's too easy. Okay. All right, so that means for something like 45, x raised to the sine x. So that fits the category of a variable expression to a variable expression. You have to do the logarithmic differentiation. See, we don't want that sign way up there. So the question is, how do I get it down? To get it down, take the log of both sides. Okay, so ln both sides, ln y, ln x to the sine x. Once you do that, that sine x gets to come down in front. And now I can handle it, right? I don't want that sign floating up there. I want it to come down. So it's like this. Okay, the left side for the next step is always the same. It never changes. 1 over y dy dx. Okay, you differentiate implicitly. Remember implicit differentiation. Okay, this side only has x's, so I just do the regular derivative. This side does a y, so once I do the 1 over y, you have to tack on a dy dx by the chain rule. Okay, this looks like the product rule. First function times the derivative of the second, 1 over x, plus the second function, ln x, times the derivative of the first, derivative of sine x, is cosine x. Okay, and then the next step is always the same, multiply both sides by y, but don't leave it as y, write what it originally was, and sneak it in front. Okay, so what was the original y? X raised to the sine x. So final answer, dy dx is x raised to the sine x, and then times this stuff, clean that up a little, sine x over x plus cosine x ln x. Okay, I just put this back with the cosine first, but otherwise it's the same thing. Okay, and yeah, let me raise this up again so you can see it. Okay. All right, there was only one more I was going to show you, but I did get a request for 3.449. It was kind of messy. Let me go back to 3.449. Page 204. 49, y equals square root of 1 minus secant t. Find y prime and y double prime. The y prime isn't so bad. The double prime is the one that's worse. Okay, so I'll show you what I have for that one. Okay, y equals square root of 1 minus secant t, which is 1 minus secant t to the 1/2 power. So this one, you really get to use your trig derivatives. All right, so outside function is square root, which means raising to the 1/2. So y prime is 1/2, 1 minus secant t to the negative 1/2, times the derivative of the inside. Derivative of 1 is 0. Derivative of negative secant t, the coefficient is negative 1. So it's negative 1 times the derivative of secant t, which is secant t tangent t. Okay. Again, derivative of secant is secant tangent. Okay, a little bit of touch up before I do the second derivative. negative in front of the whole thing, 2 on the bottom, square root on the bottom, secant t, tangent t on top. So that's the thing I have to worry about for getting the second derivative. It's a quotient rule, and the top even has a product. So there's a product rule inside a quotient rule. Okay, now, you can pretend there's a coefficient of -1/2. So take out the -1/2, it's over and done with. It's -1/2 times that. Therefore, the derivative is -1/2 times the derivative, the rest of the stuff, which is all of this. Okay, so that -1/2 is out of the picture. I don't have to think about it anymore. Okay. Now I just have to worry about that, and that, right? Okay, so here we go. It's bottom times the derivative of the top. So bottom. Now the derivative of the top, secant t, tangent t, that derivative is a product. So I need the product rule for that. So first function, secant t, times the derivative of the second, secant squared, plus second function, tangent t, times the derivative of the first, derivative of secant t, tangent t. Very messy. Okay, what did I just do? That was bottom times derivative of top, minus the top. There's the top. Times the derivative of the bottom. Remember that 2 is out of the picture. So now when I differentiate the bottom, it's 1 minus secant t to the half. Whose derivative? Well, we just did that up there, right? 1/2, 1 minus secant t to the -1/2, times the derivative of 1 minus secant t, which is negative secant t tangent t, all over the square of the denominator. So it's a square root squared, just that. Okay, I'll just leave it like that. This one is so bad, as you can tell, we're not going to fool with any more algebra with that one. Just leave it like that. And that's good enough, or bad enough, I guess, because it's so messy. Okay, I was going to do just one more, and then I'll stop and give you the quiz, because then I'll be done with the section. So I think we're on par schedule-wise. So complete 3.6 by today. Okay, so next week, 3.7, 8, and 9, and a quiz. And then the following week, just before spring break, 3.10, 3.11, and our tests, and then we're off for a week. Okay. Okay, last one I was going to show you is 3.6, number 49. Let me see if that's the one I wanted to do. Yeah. 3.6, 49. Yeah, maybe I didn't get a chance to focus this on you. Let me show that again. Raised up if you want to catch the video later. Well, maybe it's kind of hard to put all this in one screen. Yeah. Okay, and just in case I forgot to do that over here, if I did, then you get to see it again. Anyway, a little bit better focus. Okay. Okay, 49. Tan x raised to the 1 over x. So again, variable, variable, do logarithmic differentiation. So ln both sides. Once you do the ln both sides, the 1 over x comes down. And if it's 1 over x, you might as well write it like this. Ln tangent of x divided by x. So natural log of y equals 1 over x. Ln tan x is the same as natural log tangent x over x. Okay, then differentiate implicitly. The left side's always the same. 1 over y dy dx. Okay, equals. Now the derivative of the right-hand side, so it looks like a quotient rule. Bottom, x, times the derivative of the top. So derivative of natural log tangent of x is 1 over tangent x times the derivative of tangent x, which is secant squared of x, chain rule, minus the top, natural log of tangent of x, times the derivative of the bottom, but the derivative of the bottom is 1, so you don't even have to write it, all over x squared. Okay, and multiply both sides by y, and that's it. So dy dx is y. Don't leave it as y. What was the original y? Tan x raised to the 1 over x. So there's my y, tangent x to the 1 over x. And then I just cleaned this up a little bit. X. Okay, I got 1 over tangent x. So 1 over tangent x is a little bit cleaner if I write cotangent x. Secant squared x minus natural log of tangent of x all over x squared. And we'll just leave it like that. That's good enough. Okay, and let me raise that up a little bit more so you can see that a little bit better. And that's it. And don't look at problem 7. That's for the next section. I'll start that on Monday, most likely. Okay. All right, folks, I'm done. Anybody have any questions? You can either unmute yourself or put it in the chat now. Otherwise, we'll go straight to the quiz. Okay. I know some of you put something in the chat about attendance coming in late. If you ever come late, of course, put it in the chat and go from there. All right, quiz time. So get your cell phones out or be ready to do a screenshot as usual. Okay, I'll put you in your breakout groups as usual, and that'll be it for this week. Okay, so here we go. Find dy dx. Number 1, y equals x sine of pi x. That looks like a product rule and also a chain rule. Number 2 looks like implicit differentiation, right? 2x squared plus xy minus y squared equals 6. Number 3, f of x is natural log 1 plus x squared. So you have to know how to do the derivative ln and a little bit of chain rule. Okay, so I'll hold it for maybe 15 more seconds. I'll put you in your breakout groups. Put your first and last name and first and last name of everybody on your team. Okay, as usual, I will grade only one person on the team. So the only way you can be sure of getting it correct is to make sure everybody gets it right. So once you finish, don't just stop. Make sure everybody else on your team has it right also. Okay, I'll read it again. Number 1, y equals x sine of pi x, product rule and quotient and chain rule. Number 2 looks like implicit differentiation, 2x squared plus xy minus y squared equals 6. And number 3, f of x equals natural log 1 plus x squared. Okay, I will now assume that everybody has it. So get started. I'll set up the breakout rooms. I will turn off the recording also, so no longer recording. And set the breakout rooms. All right, looks like you're going to have either 4 or 5 most likely, and Prasanna will visit room from room to room perhaps, and we'll see how it goes. Okay, you should get an invitation to join your breakout room. So can everybody join your breakout room, please?